ViaLite Communications, who are we and what do we do? Yeah. So ViaLite Communications is a division within our company called Pulse Power and Measurement. The company was founded in 1994, and we are a subsidiary and fully owned by BAE Systems. So what we get involved in is aerospace and defense projects. We get involved in time and synchronization, and also some secure defense programs around the world with different organizations, from Air Force to Army and also naval applications. So ViaLite Communications has been developing fiber optic links for approximately 25 years now. And we are one of the leading suppliers of fiber links for different applications. Everything that we do, we actually go through and manufacture and design and test all in the UK. So we have an engineering team that will go through and make sure that the performance of what we actually specify is what we actually deliver for customers around the world. One of the biggest markets for us is the Satcom market. And basically we supply 8 out of the top 10 teleport operators globally around the world. So what is our main product? So one of the main products that we do is Satcom. So with Satcom, we're talking about L-band transmissions, which are coming from a satellite antenna, and we're transporting it in the downlink direction and also in the uplink direction. In terms of the frequency ranges, we have a full range of different frequencies, from IF frequencies through to L-band, S-band, C-band, also 10 meg, and also GPS and GNSS, fiber optic links. Now, you can see over here that this would be a typical setup. We could have something that could range between about 100 meters as a fiber optic link, but we can go up to about 600 kilometers if we need to. We've got the technology to actually develop and deliver solutions globally around the world, which can cover up to around about 600 kilometers as a fiber link.
600 kilometers is almost the length
of Israel, yes, absolutely. Yeah. So the good thing is that the way we operate is we actually go through and make sure that the performance of our fiber optic links are world-class and and leading in technology. We have a spurious free dynamic range of around about 115 dB per hertz, and also very low noise figure as well. So as part of our developments moving forward, we're always looking to develop our offerings. So under development at the moment, we've got Ka band, which is going in the 30 gigahertz range, and also we're developing solutions for X-band for government and defense applications as well. So at the bottom you can see over here, these are some typical customers that we actually supply to. So we have SES, we have Telesat, Hughes, Telespazio, and Intelsat. Intelsat is one of our biggest customers, and we supply globally out of the US to all the facilities. So one of the main things that we actually do is we actually go through and we can actually provide a fully scalable GNSS or GPS system. So as part of a system that a data center or a telecoms provider may want, we're able to actually go through and build up a system using the equipment that we manufacture to deliver solutions that can be expanded upon from day one. You could have a simple link with a GPS antenna and a fiber optic link going into an NTP server. But over here, what we've actually done is we've worked with Focus Telecom and the team over here to actually go through and incorporate the Focus Telecom Resilient Kit into a data center operation. So at the top, you can see we have the Resilient Kit, and then moving down, we have an outdoor enclosure, or we have an outdoor fiber optic module. We can go into a fiber termination box, and then, I wonder if this has got a laser pointer. Yeah. And then over here, we have what we call a lossless optical splitter. So this device over here is actually designed to take the GPS signal that we've actually got, convert it into optical, and then we can actually go through and split losslessly up to 64 ways. And then from here, we can go into our 1U chassis, and inside of these 1U chassis, we have RF splitters after we convert it back into electrical form. So each one of these receivers, you can have up to 16 outputs. So if we look at this particular system over here, the way it's actually set up, you can actually go through and have up to 256 outputs for NTP servers, for base stations, or any other devices where GPS signal can be transported across a fiber network into that type of device. If I was to look at the lossless optical splitter, and if I used all 64 outputs and 16 outputs out of the individual receiver modules, I could get up to, I think it's 1,028 outputs out of it. So you can see over here we have a fully scalable solution. Yeah, you don't have to populate all of these from day one. You could actually go through and populate it as time goes on. So, what does a GPS signal look like after a fiber link? So using a U-Blocks evaluation kit, basically what I did was put a GPS antenna up, put it over a fiber link, which was, I think it was 10 kilometers, and basically converted it back, and this is what we saw. So it was exactly the same as getting the information from an antenna directly. So from here you can see we have 24 satellites that are still present across a fiber network, which works really well for any kind of NTP server that needs time and synchronization going into it inside of a building. So one of the things I wanted to talk about is a new product that we actually launched recently. This is known as our Mil-Aero product. It's a fiber optic link that covers up to 6 gigahertz. So this link actually works from 10 megahertz all the way up to 6 gig. It was designed for aerospace and defense markets. The US Air Force was behind this in terms of using it for applications in their setup in the US. And we went through and developed this solution so that they could use this for a specific application, which I want to talk about on the next slide. So we traditionally have our normal rack cards. We have what's known as our Blue OEM. So this has been recently redesigned. So it uses all the latest technology available on the market. And what's new now is we've now come out with this IP-rated outdoor fiber optic module. So this module can be used directly outside, right next to the antenna, IP-rated with a IP-rated power supply as well, and can be left out in the elements to work as normal. In fact, the Mil-Aero product can work up to 7 gigahertz at the 3 dB point. And with this particular option for aerospace and defense applications, we basically have 3 different options available, which are standard, high gain, and high output. So where does it get used? So from an aerospace and defense market, basically for tracking, telemetry, and control. That is the primary focus of this particular module. So these modules are basically installed near a parabolic antenna, and basically it is used to collect information from flight test instrumentation data, tracking objects that are going through the sky, and also backhauling the information from these antennas into your mission control room. We cover the L, S, and C bands, and we go up to 5150 megahertz for tracking, telemetry, and control, even though the modules can go up to 7 gigahertz if they need to. In the US, they call this Boresight testing. So you can see over here, this picture was taken at Edwards Air Force Base in the US. They qualify the product for use for tracking, telemetry, and control, and it's been implemented across other Air Force bases around the world as well. So how does it work? So quite simple. You have your antenna, you would have some kind of low noise amplifier, and then you have an electrical to optical conversion. We convert the signal, we put it over fiber, and then we convert it back into an electrical coax output coming out. And then that gets fed into any other equipment that may be installed within the facility. So this is a standard gain link product, and basically we can take a number of different input levels going into the module and have the same input output level coming out at the other end. If we look at the uplink direction, if you're sending information that goes back up to an aircraft, for example, you're basically going through and sending a signal, which could be at 0 dBm, that gets sent over a fiber optic link and transmitted back up to your aircraft or any other kind of system that's flying around. So what we have here is a high output level pair. The good thing about this is we have a 0 dB signal coming into it, we're converting it. You've got minus 12 dB that is set on the transmitter. We have a little bit of optical loss. We can overcome that loss as well by putting more gain in on the receiver side. And then we can have a plus 10 dB output going directly into the antenna to be sent up to your projectile or aircraft that way. So it makes it an ideal product for use for aerospace and defense. So you can see over here, this is probably the most common form factor that a lot of customers of ours take, the Blue OEM product. It's a small, compact unit, can be powered with its own power supply, or it can be integrated into customer equipment as well. The good thing about this is it's small, it consumes very little power, and it can be built quite easily, and nobody will know that it's a fiber optic product that's inside there. So generally, it comes with FC-APC fiber optic connections or SC-APC. Everything is a 50 ohm SMA connector, and basically there's different connections that we have for getting information out, using a standard power supply, 12 volt power supply that can be used. And one of the new things that we've done now with this particular product, we've actually gone through and put a USB port on there so that you can actually go through and interrogate and change things if needed on the product. So if you have multiple solutions, The Mil-Aero product, like I mentioned, it goes from 10 meg all the way up to 7 gigahertz. You can put GPS down there, you could put a 10 meg signal down there, you could put an L-band signal if you wanted to, and basically you can build this into multiple antenna solutions. So you can see over here, 4 modules in an enclosure with dual redundant power supplies, being connected together across a quad cable. So it's a fully scalable solution that can be developed and deployed if required across any kind of site. So the black OEM, quickly wanted to mention this. Our GPS customers have now decided that the black OEM is a suitable solution to be deployed for outdoor use right next to a GPS antenna. So we can deploy this outside. And the good thing about this product is we have the option to actually go through and power the antenna directly from the module itself. So if you have a 5-volt antenna or a 12-volt antenna, we can actually power that antenna or any other equipment, like the Resilient kit, for example, directly from our module. The good thing about this is it has this USB port as well, so you can actually go through, connect onto the actual module, and actually change the settings if you need to. So you could change it from a 5-volt antenna to a 12-volt antenna, for example. You can actually go through and interrogate things as well from here, and basically go through and make sure that all the levels and the settings that you have can be changed. So we've had a lot of customers that have taken this particular product and are now designing it in as part of their GPS setup for time and synchronization, for NTP servers, for base stations, and it's starting to gain traction around the world as a solution for outdoor use for time and synchronization. So you can see over here with the USB access, basically there's a command line interface which you can use over PuTTY, for example, and you have the ability to go through and interrogate and change settings according to gain, to receive light level, providing power, AFD, which is antenna fault detection, which I'll tell you about in a minute, and also change system parameters. Now, with all the cards that we normally do with our chassis type products, we have a single TX, we can have a single RX. We can also do a dual TX, and we can do a dual RX product as well. And we can also do a transceiver product as well. With the chassis itself, we have 13 slots that we can fully populate. So we can actually have up to 26 fiber optic links in a single chassis if needed as well. The product itself integrates with our SNMP, so you have a web GUI interface that you can actually go through and basically interrogate and change settings and set up alarms, etc. That allows you to actually maintain and make sure that everything is functioning correctly. So one of the things is the bias T. Yeah, so we put this bias T into the product to allow you to actually go through and feed power up to the antennas. There's various different options that we have where you've got no LNA feed. So if you didn't want to put power, you don't have to. We have +5 volts with 80 milliamps that could be supplied for powering an antenna. And then we have +12 volts with 350 milliamps that allow you to actually go through and provide power as well. And then if there's something else, you can actually feed that feed in automatically into the actual modules as well through the integrated bias T that we have. So one of the things that we have is this antenna fault detection. As part of the setup of these particular modules for GPS and GNS type applications, we have this antenna fault detector. So if something goes wrong with your antenna, maybe a lightning strike or something's damaged it, somebody's banged into it and that, we have the capability to monitor the current that is being drawn by the antenna. If that value changes or drops down to more or less zero, our TX module knows that there's a fault with the antenna. So what it does is it automatically switches off the laser in the product and stops transmitting light to the receiver. So your receiver then realizes there's no light coming in, so it will alarm and send that signal to your NTP server or your base station to say there's an antenna fault on the actual product. These thresholds for current can change. It can be configured between 2 milliamps and 200 milliamps, and basically a receive light level alarm can be switched on as part of this. Now, in terms of performance, a lot of people ask us about noise performance, how good the fiber optic link is, will it work in a noisy environment where there's lots and lots of other signals, and how well will it actually go through and cope. So if I look at our standard gain link over here, basically you can see we have a TX gain and we have a RX gain. So if we come along and look at these two, you can see that the overall gain is 5 dB. With different settings, you can see over here what our spurious-free dynamic range would be for aerospace and defense applications, the IP1, the IP3, and also the noise figure. So just by changing the gains on both the TX side and the RX side, you can play around with the actual performance of your fiber optic link. So you can see over here, I've kind of done tables for 1.5 gig, which will cover the GPS side of things, and also 5 gig as well on this particular product. Now, if we were to look at the high gain option for aerospace defense type applications, basically we can actually go through and play around with the gain settings further. So you can see over here we have a TX gain of 5 and we have 15 there, so you've got plus 20 dB of gain that you can actually put into your system. If we went even further, you can see over here, just by changing the gain, the noise figure that you're actually getting, it improves. So you're looking at around about 6 dB of a noise figure. So this is really important for governments and defense type applications around the world. And again, with the 5 gig range, you can play around with it. These tables are available on our data sheets, so feel free to have a look at it as and when you need to. So in terms of final words, the product itself, it's a new product. It's been developed as part of our next generation fiber optic links, designed for government, defense, time synchronization type applications. So we can cover from 10 megahertz all the way up to 6 gigahertz. And we have VHF, UHF, L-band, S-band, C-band options. We have the high gain and high output options, low noise figure. And one of the other important things is that as standard, we are now implementing 1550 nanometers on these products to give you the lowest loss possible on a fiber optic link. And the good thing is, it's cost competitive. So speak to Focus Telecom. They'll be able to provide you with the information with regards to this. And if you have any questions or want to know more about it, please come and see me throughout the day. I'll be available to discuss this. So we have on the website the product, we have the tables, and we have data sheets available. Feel free, download it, and come back to me if you have any questions. Thank you.